Assalamualaikum and hi, my name is Aqilah Hanis binti NURAZHAR with a metric number 019414266. So today, I would like to present our database project named Industry Practical Registration for ECOLE8 under MARii program. First and foremost, we need to identify the problems occurred. Therefore, I personally interviewed the owner of the ECOLE8 company virtually, as the owner of the company is my own boss and I work part-time as a help desk in that company. However, the ECOLE8 company has been facing several problems. We will go look on it one by one. Firstly, the company is using a platform of Google Form to collect data from applicants. In large-scale data collection, this method is very inefficient to use. This method may trigger different issues during processing the data. For instance, the Google Form may crash or missing as the mass data stored in. Moreover, the ECOLE8 company's employee is having difficulty accessing the data gathered. They need to verify that the information needed has been filled in and in compliance with the specification set. This process taken a long time because it needs to be checked one by one. This issue will lead to work stress as the system used is not user-friendly. Besides, data inconsistency may occur due to the employee careless. The employee may overlook when the participants refill the form to make changes of their details. The data stored in the company system will be inaccurate and cause some confusion. The employee will have difficulty in making the report. Last but not least, the employee has to keep a lot of hard copy of documents received from the participants. It needs space to properly store those records. It is also difficult because the document is likely to be lost or misplaced. Therefore, from this issue, we have to say that the current ECOLE8 company system is inefficient and lack of proper storing data. Next, HAIKAL will be explaining about the database objective.
We move on to the database objective. These are the 4 elements. The first one is data deletion. The objective is to avoid deletion anomalies and to delete the data accordingly. It allows the employee to minimize their workload and to make sure data are stored precisely. Second, data integrity, which is the objective is to make sure they have a reliable, authentic and consistent database. The third one is data protection, which is to make sure that data that they stored are safe from natural disaster. Finally, to provide sufficient and efficient work handling to make sure that least mistakes are made by employee and short time are taken to compile the data. So I will pass to the next presenter, Hanis, to present about the ERP.
Hi, I am Hanis. I will explain the entity relationship diagram that this project entails. In this diagram, the first relationship is student and application. One student can fill out several applications, and only one application can fill out by one student. Then, the employee will collect and compile the application. The weak entity between these entities will be established since their relationship is many-to-many. The student also will be assigned to many classes, and one class can be attended by many students, which make the weak entity student class emerge to determine the student result. The class entity also has relationship with lecturer entity. One class can be taught by one or more lecturers, and one lecturer can teach one or more classes. Lastly, the student will be assigned to their suitable placement. One student can be assigned to one placement only, and one placement can receive many students. The next explanation will be continued by HAIKAL.
So we are here in this creating table section, which is I will create 9 tables in this database. So the first table that I will create is student placement. So this is the syntax to create the student placement table. So we need to create table student placement, and then we need to put four attributes, which is placement ID, placement name, placement address, and placement tel. For placement ID, we need to set the data type is voucher 10, voucher 10 which is the size of 10, not null and unique, because we need to set the placement ID as a primary key, and then placement name with the data type of voucher size 50, not null. And then we need to set the data type for placement address, which is voucher size of the length of 100, not null also. Finally, placement tel, the data type is voucher 20, not null. So this table is not recognized the primary key yet, so we need to set the primary key by this syntax. Primary key, put the placement ID in this bracket, and then close it. And so we can run it now to check whether our table can be created, and then yes, successfully. So we can check now our table. There you go. So second, I will create student table. So same like previous, create table student. We need to put all the attribute in the student table, which is student ID, stu ID, stu name, stu email, stu tel number, stu tel num, stu qualification, stu address, stu account, and the placement ID, which is this is the foreign key in this table, but it is the primary key in the student placement table. So the student ID we need to set voucher 10, not null and unique, because we need to set the stu ID as primary key. And then stu name, which is the data type is voucher, the length of 50, not null. Third, stu email, which is the data type is voucher, and also the length is 50, not null. Then stu tel num, which is the data is voucher also, with the length of 12, not null. Moreover, we set the data type for stu qualification, which is voucher with the length is 10 and also not null. Stu address with the data type voucher 100, not null. Stu account bank, voucher with the size of 30, not null. And for this placement ID, we set the same data type with from the student placement table, which is voucher 10, but it is not null. Just leave it there, nothing. So same like the previous table, we need to set the primary key in this table, in the student table, which is stu ID. So we need to put primary key, student ID in this bracket, and then we need also to set the foreign key, which is the placement ID. So we need to put this foreign key, placement ID, and plus this reference to placement, which is it will refer the student placement table, and put the name placement ID from the student placement table. So it will recognize the foreign key is linked with the primary key in the student placement. So we can highlight it and run it. There you go, it's working, so we can check it. There you go. Next, I will create the third table, which is class. So create table class, and then we need to put the 3 attribute, which is class code, class hour, classroom. For the class code, we set the data type as a voucher with the size of 10, not null, and unique because we need to set the class code as the primary key. And then class hour, which is int3, not null. And then finally we put the last attribute, which is classroom baca with size of 40, not null. Same like the previous tables, the table is not assigned the table is not set the primary key yet, so we need to set it. So this is the syntax, which is we type primary key, put the class code in a bracket, and then we close it. So we can try to run it. Okay, this is the occur warning, but this is not a problem because we can see our table. Yeah, there's no problem with that. And then I will create the next table, which is to class. So same like the previous one, we need to create tables to class, and in this table, this is the bridge entity table. So we need to put the to ID baca 10, same like as previous table in the student. Class code baca 5, same like in the student placement, same like class table. And then we need to put another additional attribute, which is result. We set it as a data type for baca 20, not null. In this table, we need the to ID and class code is the primary key and foreign key. So we need to set it first with this constraint pk to class primary key, and then we need to put all the attribute in this table, and then we need to set the foreign key to ID reference to the student table, and then put the student to ID in this bracket. And finally, we need to set the class code as a foreign key with this foreign key class code, reference the class table, and then put the class code in the bracket. So we can run it. Okay. Oh, sorry. There you go. Okay, next I will create the table lecturer. Okay, same as before, create table lecturer, and then put this 5 attribute, which is lec ID, lec name, lec address, lec tel, and salary per hour. For lec ID, we set the voucher of 6, not null, and unique because we need to set it as a primary key. And then lec name, voucher, the data type is a voucher with a size of 60, not null. And then lec address, voucher of size voucher with a size of 70, not null. Lec tel, voucher of 13, not null. And finally salary per hour, decimal 8 2, not null. So we need to set the primary key lec ID. So this is the syntax: primary key lec ID. So let's run it. There you go. The table is be created, and show the table. There you go. Then we need to create lec class table, and this is also the bridge entity table. So we need to put lecturer ID, which is this, it is from lecturer table with a voucher of 6. Class code, this is the primary key in the class table with a voucher of 5. And we need to put another additional attribute, which is the module, voucher of 50, not null. So we need to set the index lec ID, index class code. Same like before, we need to set the constraint pk lec class, primary key lec ID, lec code, module. You need to put all the attribute in this bracket. Constraint fk lec class, foreign key lec ID. So we need to set the the lec ID also as a foreign key. Reference the lecturer table and put the lecturer ID, which is it is the primary key in the lecturer table. And finally, we need to set the foreign key for class code, which is syntax constraint FA class to foreign key class code, and references the class, which is it will reference the class table with this class code, which is the primary key in the class table. So we can run it. There you go, and let's see the table. There you go. So we move on to the employee table. So I will create the employee table, which is we need to put so we need to put this attribute, which is EMP ID, EMP IC, EMP name, EMP email, EMP tel, EMP address, and EMP salary. So for the EMP ID, we need to set the data type as a varchar with the size of 6, not null and unique, because it is we need to set it as a primary key. And then this is EMP ID, which is a varchar of 12, not null. And then we need for the EMP name, we set the data as a varchar 50, not null. For the EMP email, we set the data type as varchar, also 50, not null. EMP tel, which is the varchar, which is the data type is varchar and the size is 11, not null. EMP address, which is the data type is varchar with the size is 50, also not null. Finally, EMP salary, which is the data type is decimal 82, not null. So this table is also not recognized the primary key yet, so we need to set the primary key. So this is the primary key syntax primary key. Put the EMP ID in the bracket. So we can run it. There you go. Show the table. There you go. So the next I will create application table, which is these are the attribute: app ID, app attendance, app database, app and report, app health, app evaluation, app bank, and stu ID, which is this is from student table. So app ID, I set the data type as a varchar with the size of 6, not null and unique, because I want to set the app ID as a primary key. App attendance with the data type is varchar 15 and not null. App database, varchar with the size of 20, not null. App training report, varchar 20, not null. App health, varchar with the size of 10, not null. App evaluation, varchar 20, not null. App ID, app bank, varchar with the size of 20, not null. And for this student ID, we set same like primary key in the student table, which is varchar 10, and do not put anything. And then we need to set the primary key, and we need to put the app ID in the bracket, and also foreign key stu ID reference the student table. We can put the student ID, so we can create the table and then show the table. There you go. So the final table that I will create is EMP app. So we need to put these two attributes, which is EMP ID from the EMP table and app ID from the application table. So the data type is same like the EMP like the employee table, which is the varchar 6, and do not put anything. EMP ID varchar 6. So we need to connect it. So constraint pk EMP app primary key, put these two attribute, and then we need to set the foreign key for EMP ID, references employee EMP ID, and then foreign key for app ID, references application app ID. So we can run it and show the table. There you go. So for the next section, I will pass it to Nur IZZATI. Thank you.
Today I will explain about comparison operators. Assume that variable A holds 10 and variable B holds 20. The first operator is equal to. It is to check if the value of two operands are equal or not. If yes, then condition becomes true. A equals to B is not true because A holds the value of 10 and B holds the value of 20. The second operator is greater than. It is check if the value of left operand is greater than the value of right operand. If yes, then condition becomes true. A greater than B is not true. The third operator is less than. It is to check if the value of left operand is less than the value of right operand. If yes, then the condition becomes true. A less than B is true because A is 10 and B is 20. The fourth one is greater than equal to. It is to check if the value of left operand is greater than or equal to the value of right operand. If yes, then condition becomes true. A greater than equal to is not true. The fifth one is less than equal to. It is to check if the value of left operand is less than or equal to the value of right operand. If yes, then condition becomes true. A less than equal to B is true. The last operator is to check if the value of two operands are equal or not. If values are not equal, then condition becomes true. A not equal to B is true because A is 10 and B is 20. Next, I will explain simple query comparison operator. For question 1, display the lecturer ID, lecturer name, and salary of all lecturers where the salary is greater than 50 ringgit per day. So this is the query for question 1. Select lecturer ID, lecturer name, salary per hour from lecturer table where the condition is using where clause, salary per hour more than 50 ringgit, and this is the output. I will run in my SQL. I will run the query and it will return 15 rows.
And it will return who's the lecturer have salary per hour more than 50 ringgit.
The second question is retrieve all data from application table in which the app ID is alphabetically less than A0006. And this is the query for question 2. Select all data from application where the condition is app ID must less than A0006. And this is the output. I will run in my SQL. I will run the query and it will return 5 rows.
That the application ID is less than A0006.
And the last question for comparison operator is retrieve all information about student class table where the result is pass. Sort the result by student ID descending. So this is the query for question 3. Select all data from student class where the condition must be pass and sort the result by student ID descending. So we must use order by and descending. I will run it in my SQL. I will run the query and it will return all the result is passed here, and that's all for comparison operator. I will pass to HAIKAL.
Okay, in this section, I will share to you how the logical operator work in our database. So the first question is display all lecturers between L0003 and L0015 that have salary per hour more than 55 ringgit. So we need to select all from lecturer where ID between L0003 and L0015 and salary per hour are more than 55. So we copy this and run it. Alright. In this table, it shows that there are 4 lecturers in between L0003 and L0015 that are salary per hour more than 55 ringgit. So next, the second question is display all employees that email end with at ECOLE8.tech or at gmail.com. So select all from employee where EMP email like percentage at gmail.com or EMP email like percentage ECOLE8.tech. So we'll copy this. So it display the data that EMP email end with ECOLE8.tech and at gmail.com. So there are 14 employees that have email ECOLE8.tech and email at gmail.com. Next, final question is display student names and student address that are not from para. So select stu name, stu address from student where not stu address like percentage para. So B and we run it, and it display the student number and the student address which is they are not from Perak. They are from Selangor, Kuala Lumpur, Kelantan, Terengganu, Kedah and Perlis. So that's all from me. I will pass for the next session to IZZATI. Thank you.
The third operator is special operators. In special operators, it has 6 operators in it. The first operator is between operator. It is to check whether an attribute value is within range. The second operator is now. Checks whether an attribute value is now. The third operator is like. It is to check whether an attribute value matches a given string pattern. The fourth operator is in. It is to check whether an attribute value matches any value within a value list. The fifth operator is assist. It is to check whether a subquery returns any row. The last operator is distinct. It is to limit value to unique value only. Next, I will explain the simple query for special operator. The first question is list employee ID, employee name, employee email, employee telephone number, age, whose employee ID between E10 and E14. Sort the output according to employee name in descending order. So this is the query for question 1. Select employee ID, employee name, employee email, employee telephone number. And this line here will return the employee age by taking the first 2 digits in employee IC from employee table. And the condition is the employee ID was between E010 and E014 using where clause. And sort the output according to employee name in descending order. So we must use order by employee name descending. I will run the query in my SQL. I will run the query and it will return 5 rows. And this is the name or employee name descending. So the A will be at the bottom of the rows of the table. For question 2, need student qualifications, student ID and student name whose name start with letter H. And this is the query for question 2. To select student qualifications, student ID, student name from student table. And we are using the where clause for the condition, student name, and the like is the special operators. Like H%. This means the first letter of the student name must be H, and this is the output. I will run it at my SQL. I will run the query, and it will return all the student names start with the letter H, which is Hani, Haziq, Haris, Haikal, Habib, and Hafni. The last question is list lecturer ID with ID of L1, L3, L9 and L14. lecturer name, lecturer salary per hour, and the total of salary for a week, where the salary for an hour is 55 ringgit. Assume that they teach 3 hours per day. Sort the listing by lecturer name. And this is the query for question 3. Select lecturer ID, lecturer name, salary per hour, and this line will calculate the salary for a week that the lecturer teach for 3 hours per day from table lecturer, and use the condition is salary per hour must be 55 ringgit using the where clause, and using special operator which is in that used to test for values which are in the list. So it will test the value in the L1, L3, L9 and L14. And order by lecturer name because the question asks to sort the listing by lecturer name. So we must use order by. And this is the result of this question. I will run it in MySQL. I will run the query. Okay, and it will return 4 lecturer ID because in the question it asks lecturer 1, lecturer 3, lecturer 9 and lecturer 14, which is salary per hour is 55 ringgit. So this is salary for lecturer for a week. I will pass this to Hanis.
Now, I will explain the question for scalar functions and arithmetic. The first question is, we need to display all the lecturer ID, lecturer name, lecturer address, lecturer per number, salary and the total of salary for 12 hours. We will use select lecturer ID, lecturer name, lecturer address, lecturer tile per number, salary per hour, and salary per hour times by 12 and save it as salary for 12 hours from lecturer. From the query, we will get this output. The next question is, display all the employee ID, employee name, employee telephone number and salary with 5% bonus. For this question, we will select employee ID, employee name, employee telephone number and employee salary plus employee salary multiplied by 0.05% and save it as salary with 5% bonus from employee. This is the result from the query above. The third question is, display all the employee ID, employee name and age for all employees. We will use select employee ID, employee name, year current date to get the current year, and we will use substring to get the year from the employee IC and save it as age from employee. Here is the result from the query above. Next, we will continue with column functions and grouping. The first question is, write a query to count the number of students in each class in ascending order. We will use select distinct class code, count result as number of students from to class, group by class code, order by count result ascending. Here is the result. The second question is, display the employee ID, name, address and salary of all employees that are not from Perak and the salary lower than 4,000 ringgit. Sort the result in ascending order of the employee name. In this question, we will select employee ID, employee name, employee address, employee salary from employee. The condition in this question is employee address not like Perak and employee salary lower than 4,000 ringgit. We will use order by employee name ascending. This is the output for the query above. Last question, we need to write a query to show the difference between maximum and minimum employee salary. We will use max and min function to find the maximum and minimum salary. Then we will subtract the maximum salary with minimum salary to find the difference. Here is the output from the query. The next topic will be continued by IZZATI.
I will explain a bit about joining database table. Join is performed when data are retrieved from more than one table at a time. It is done by matching foreign key and primary key of related table using equality operator. To list out student ID and student name from student table and placement name from student placement table, the placement ID from both table is used as the linking attribute. The syntax of the joining query is select table name 1.column name and table name 2.column name. The table name here, you can replace it with correlation name such as s.studentID and s.student name from student table and student placement name. The where clause here is the join predicate from both tables that using primary key and the foreign key. For question 1, for every student, list the student ID, name, telephone number, application help, and application bank. Then sort the output according to student ID in descending order. This is the query for question 1. Select s.studid, student name, student telephone number, app health, and app bank. The S here is the correlation name for student table, and the student ID here is belongs to the student table, same as here. Application health is belongs to the application table from student S, application A. The where clause here is the join predicate for student and application table, where the foreign key and primary key is student ID, and sort the output according to student ID. So we use order by to sort the student ID by descending order. So I will run the query. I will run the query, and this is the output. It returned 20 rows. The second question is display lecturer ID, lecturer name, class code, hour of class, and module the class is using, where the class is 6 hours. Then sort the output according to class code in ascending order. So this is the query for question 2. Select lecturer ID, lecturer name, class code, class hours, and module. This query have 3 tables, which is from lecturer table, class table, and lecturer class table. It must have 2 join predicate, where the one join predicate is from lecturer and lecturer class, where the primary key and the foreign key is lecturer ID, and another join predicate is from lecturer class and class, where the primary key and the foreign key is class code, and the condition is where the class code is 6 hours, and sort the output according to class code in ascending order. So we are using order by. So I will run the query. So I will run the query, and it returned 2 row, which is Shanti and Mira,
And only return the lecturer name who teach for 6 hours.
The third question is retrieve information about student ID, student email, placement ID, and placement name, where the student ID more than and equal to S0003. So this is the query for question 3. select x.student ID, student email, p.placement ID, placement name. From student table, join student placement table using placement ID, where the placement ID is the foreign key and the primary key for those table, where student ID is more than and equal to S0003. I will run the query. And it will return 18 row.
Thank you, IZZATI. Next, I'll be explaining about the subquery. A subquery is a query that inside a query. It is using a select statement. A subquery also usually enclosed within parentheses. The first query in the SQL statement is known as the outer query, while the query inside the SQL statement is known as the inner query. The inner query is executed first. The output of the inner query is used as the input for the outer query. The entire SQL statement is sometimes referred to a nested query. Next, the subquery can return one single value, that means one column in one row, and a multiple value, which is one column and multiple row. The clauses used in the subquery is where, in, and having. Next, we'll be moving on to the MySQL to run the query. The first question is, list the lecturer ID, lecturer name, class code, and class hour that higher than minimum hour. Therefore, the command is select LC lecturer ID, L lecturer name, LC class code, and C class hour from the lecturer class LC, lecturer L, class C, where L lecturer ID equals to LC lecturer ID and C class code equals to LC class code and C class hour more than select minimum class hour from class, grouped by LC lecturer ID. Let's compile it. Therefore, this is the results. Next, the second question is displays employee ID, employee name, and application database that store in application which the name is DB002. Therefore, the subquery is using in clause. The command is select EA employee ID, E employee name, A application database from employee application, employee and application, where EA employee ID equals to E employee ID and EA application ID equals to A application ID and EA application ID in select application ID from application, where application database equals to DB002. Let's run the program. Therefore, this is the result. The employee ID, employee name, and app database of DB002 is displayed. Last but not least, the third question is list all employee ID, employee name, employee address, and employee salary from Selangor and the salary lower than average of employee salary. Show the list in descending order of employee salary. Therefore, the subquery is using having clause. The command is select employee ID, employee name, employee address, and employee salary from employee, where employee address like Selangor having employee salary less and equal to select average employee salary from employee, order by employee salary descending. Let's run the program. Therefore, this is the result. So, we have come to the end of our presentation. Thank you for watching. Bye bye!